The history of telescopes, from Galilee to Hubble. We are all attracted by beauty and mystery. In fact, all of the most fascinating landscapes are those which we can't see the end, those that we're not able to explain. And nothing is more unattainable than stars. Nothing awakens our soul like them, unique comrades for night-lone travels in ancient eras before the invention of electricity. Men stare to these shiny objects in the night sky since from prehistory, when the first representations of lunar cycles were depicted in caves, together with images of animals and hunting. Another great example of this irresistible quest for stars is the myth of Icarus, who tried to reach the sun with his wax wings dramatically losing his life. An intense desire of understanding stars is what drives the research of hundreds of astronomers that study these breathtaking celestial bodies. But sometimes, as the Greek myth shows, our instruments are not sufficient to reach our tasks, and we need a technological discovery to boost our studies. Do you know what is the first great device that represented an incredible development for physics research? The telescope. When was it invented? Who first used it to observe stars and planets? How has it developed throughout the centuries? What are nowadays most important devices? Are they really different from previous models? These and other questions are the theme of this video, so if you are interested, stick with me and prepare to a wonderful journey through the history of telescopes. This device is a complex system of lenses and curved mirrors that can be used to observe distant objects and study their radiation. It's the main element which made us able to point our eyes up above the sky towards those mysterious bodies that populate the darkness of the night. However, its usage and structure has changed a lot over the centuries. Consequently, we must investigate the origin of this powerful instrument to understand its evolution. What is the first trace of the existence of the telescope? The earliest existing record is a 1608 patent submitted to the government in the Netherlands by Middelburg spectacle maker Hans Lippershey for a refracting telescope with the famous description, "for seeing things far away as if they were nearby." The actual inventor is unknown, but word of it spread through Europe. And do you know at that time who was trying to study stars and planets, unveiling incredible secrets that brought to the creation of the scientific method? Galileo Galilei. Born in Pisa, the Tuscan astronomer was initially forced to study medicine by his father, but after attending a lecture of geometry, he convinced his parents to let him dedicate to mathematics and natural philosophy. He proved to be brilliant, and he managed to obtain the chair of mathematics in 1589 in Pisa. After that, he moved in 1592 to teach mathematics, geometry, and astronomy in Padua. Considered the first real physicist in history, Galileo was also a great engineer, and basing on Lippershey's description, he was able to build the first telescope for astronomy. As a matter of fact, Dutchmen used this device for military purposes. And how did the Tuscan scientist hear about the telescope? Galileo Galilei was in Venice in June 1609, and there heard of the Dutch perspective glass, a military spyglass, by means of which distant objects appeared nearer and larger. Galileo states that he solved the problem of the construction of a telescope the first night after his return to Padua from Venice, and made his first telescope the next day by fitting a convex lens in one extremity of a leaden tube and a concave lens in the other one. In his subsequent projects, the astronomer was helped by Marco Antonio Mazzolini, an artisan coming from a family of clock producers. This is the first example of a collaboration between natural sciences and industry, intended as a cooperation of theoretical knowledge and technical skills. What were the characteristics of Galilei's telescope? Differently from Lippershey's one, Galileo found a way to reconstruct the direct image of distant objects. What does it mean? These devices were based on geometrical optics, mainly on refraction. By using a lens, they were able to magnify what they were pointing to, but they produced a flipped-over image. If the original model just had around 2 times or 3 times magnification, Galilei's one reached the absurd value of 23 times magnification. These powerful instruments helped to make a lot of important discoveries. The famous astronomer, the satellites of Jupiter, hills and valleys on the moon, the phases of Venus, and observed spots on the sun. Imagine his surprise when he understood that planets and satellites were not perfect objects as the ancient models suggested, but they were similar to our Earth. These discoveries were crucial to point to the validity of the sun-centered Copernican system over other Earth-centered systems, such as the one proposed by Ptolemy. Moreover, Galilei was the first one to use the term telescope, which comes from the Greek tele, far, and skopine, to look, a perfect definition for an instrument that helps to look at distant objects. Although its importance is undoubtful, these instruments needed a lot of improvements that were made by the famous Johannes Kepler. In his Catoptrics in 1611, he suggested the construction of a telescope with two convex lenses. The British William Gascoigne pointed out at the advantages of such a structure, but it was not till about the middle of the 17th century that Kepler's telescope came into general use. Not so much because of the advantage underlined by Gascoigne, but because its field of view was much larger than in the Galilean telescope. Do you know what is the first great discovery made with a Keplerian telescope? In 1655, Christian Huygens discovered the brightest satellite of Saturn, Titan. Nowadays, this celestial body is one of the most studied because it might hide new form of life. Let's point out the main problem of Keplerian telescope. The images furnished by this device were affected by chromatic aberration. What does it mean? Lenses have a different refractive index for each wavelength that corresponds to a particular color of the radiation. Consequently, the various components of light were deviated in slightly different directions, and the final image is turned to be similar to the real object, but a bit deformed. How is it possible to solve this problem? The only thing that could be made was to build long structures along the focal axis that limited the chromatic aberration. This type of telescopes were called aerial, reaching the extreme length of 64 meters in one of Huygens' projects. Therefore, these objects weren't practical to use and neither to build. As a matter of fact, modern telescopes are totally different. Refracting telescopes had a limitation. Their focal diameter could not indefinitely grow because it's difficult to mechanically build a great lens and make it stay horizontal just with lateral support. In the second half of the 17th century, physicists like Isaac Newton understood it was more practical to utilize curved mirrors to magnify distant objects since they could be sustained more easily. It's the beginning of the era of reflective telescopes. In 1666, Isaac Newton, based on his theories of refraction and color, concluded that light could not be refracted through a lens without causing chromatic aberrations, although he incorrectly concluded from some rough experiments that all refracting substances would diverge the prismatic colors in a constant proportion to their mean refraction. From these experiments, Newton understood that no improvement could be made in the refracting telescope. Consequently, he started making experiments on reflection, and he found out that the incident angle is always equal to the reflected one for all colors. The chromatic aberration was solved. Newton's first telescope, developed in 1668, was made with a primary tin and copper mirror of circular shape and a secondary diagonal one that reflected light at 90 degrees towards the observer's eyes with minimum obstruction. Further models were made by Cassegrain that used a secondary hyperboloidal mirror to reflect light. Later on in time, in the 18th century, the history of telescopes was revolutionized by the most unexpected person, a former musician with the passion of astronomy called William Herschel. About the year 1774, he began to occupy his leisure hours with the construction of reflector telescope mirrors. He was able to build an incredible mirror of 49 inches, 120 centimeters, and a focal length of 40 feet, 12 meters, commonly known as his 40-foot telescope, at his new home at Observatory House in Slough, England. The size of the mirror is important because the largest it is, the most light can be collected to form a good image. With this powerful telescope, he discovered Uranus and made a famous catalog of more than 2,500 nebulae. However, the first large telescopes were built not until the half of the 19th century, when Foucault's studies about the construction of mirrors through deposition of silver on glass surfaces helped to build more modern research devices. What were the new characteristics of these instruments? The silver layer was much more reflective and longer lasting than the finish on speculum mirrors, and it had the advantage of being able to be removed and redeposited without changing the shape of the glass substrate. With time, telescopes became larger and larger, reaching the actual size of 10 meters of diameter. The biggest one is the LBT in Arizona, nearly 11 meters, followed by GTC in Canarias and the Keck in Hawaii. And there's more. A project elaborated by ESO, European Southern Observatory, has been launched in 2010, and it's going to build one of the most extraordinary telescopes ever. Its name is ELT, Extremely Large Telescope, and is going to have an enormous diameter of 39 meters. Today, light pollution is a problematic issue for researchers, and is surely better to observe stars and planets far away from the lights of big cities or highways. Furthermore, it's better to locate them at high altitudes because there's less atmosphere between the instrument and the star. Why is atmosphere harmful for astronomical observations? Because air can rapidly change temperatures and density, altering the light emitted by the celestial object. This turbulence makes the star twinkle in the sky, and for a researcher this is terrible since images result to be dramatically distorted. From the 80s, a new branch of optics has developed to solve this problem, adaptive optics. It is based on corrections several hundred times per second to compensate the effects of rapidly changing optical distortion due to the motion of turbulence in the Earth's atmosphere. How conclusively the most extraordinary development scientists made is another one. They managed to send telescopes in space. Why do we send them in orbit? The main reason we put telescopes into space is to get around the Earth's atmosphere so that we can get a clearer view of the planets, stars, and galaxies. These incredible instruments don't focus only on visible light, but observe other frequencies of electromagnetic radiation like UV rays, microwaves, infrared rays, and gamma rays.